Good afternoon, everyone. Welcome to today's Emerging Technology webinar series, Getting Started with Industry 4.0 for Small and Medium-Sized Manufacturers. My name is Mary Ellen Doran, and I'm the Director of Emerging Technology for AGMA. This meeting is being taped, so for those of you who are on the live event, please just put your questions right in the chat box. For those of you that are listening on demand, please send any questions to Doran, D-O-R-A-N, at agma.org, and I'll work with the presenter to get your questions answered. This webinar series has been made possible by the AGMA Foundation. For more than 25 years, the foundation has been supporting education endeavors for the gear industry. The foundation has provided more than $300,000 to students pursuing engineer degrees or technical experience, with 86% of scholarship recipients still working in the industry. If you like this webinar today, consider a donation. Thank you. Today's presenter is Akshat Thirani, CEO and co-founder of Amper. He grew up connected to the factory floor as a fourth-generation manufacturer and founded Amper with the mission to help manufacturers track and improve operations. He is a Northwestern University graduate and was featured in the Forbes 30 Under 30 list in 2019. During today's webinar, you will learn about Amper's technology. We will bring Mark Ritchie, our AGMA IoT Committee Chair, who has worked with Amper's technology at Gleason Cutting Tools, and then you'll see the technology in action. So welcome, Akshat.
Thank you so much for the introduction, Mary. Thank you all for the opportunity for having me present today. So by way of introduction, my name is Akshat. I'm co-founder and CEO at Amper Technologies, and I'm really excited to be sharing this presentation today with all of you. So a bit of my background, and it really sets the stage for why this topic was chosen. So I grew up immersed on the shop floor. My dad runs auto component manufacturing. And growing up, I'd go to his shop floor every other week to, see how the shop floor runs and really learn as much as I could about manufacturing. And I was really passionate about it and ultimately studied manufacturing at Northwestern. But growing up, I built this deep appreciation for, lean manufacturing and what it takes to really make money in a very competitive and demanding industry. And also, as a small business owner, just seeing my dad's struggle in really getting cutting edge technologies and just the hassle it would take, whether it's from IT, whether it's from integrations, to really get any kind of modern technology on the shop floor. And, working with hundreds of manufacturers across the US, the challenge of modernizing the shop floor is real. While at the same time, the headwinds that we face as an industry, whether it's in rising costs, labor shortages, continue to grow. And so that's really the mission in starting the business, was to democratize these tools and make them really affordable and accessible at scale. So the agenda for today is to share some insights on Industry 4.0, share some examples of how small and mid-sized businesses have been able to really adopt these kinds of technologies. Share a quick spiel on how our free trial program works. Mark is kind enough to drop in on this webinar and share some of his insights on this topic. And finally, we'll leave some time for some Q&A. Happy to keep this interactive, so if you have any questions, feel free to drop it in the chat, and I'd be happy to address them as we go. And finally, a demo. All right, so as we get started, I love the saying in the machining business, which is, if you're not making chips, you're not making money. And it's obviously a very easy kind of headline, but it really is rooted in how manufacturers add value for customers, right? In the Toyota production system, you're really adding value to your customers and earning based on cutting metal, not the setup times or any of the other processes that really lead up to the machines actually producing parts. And what gets measured gets improved, but the data shows that under 8% of US manufacturers have any kind of real-time or automated data collection in place. And most of the data today is logged, whether it's manually into an ERP system or some intermediate place, whether it's a tally sheet or some other kind of manual place to collect data. And this not only costs labor in labor across the team over $40,000, but the biggest price is really in that inaccuracy and delayed information. And so collecting data on thousands of assets, from CNC machines to hobbing machines, what we've seen is that the average machine uptime, including only the shift hours, is about 28%. And when we do a survey, before we kick off any implementation, the survey is, most people believe it's closer to 60 to 70%. And so there's typically a delta that exists in the reality versus expectation. And now, the glass half full is, folks have been able to really, sustain as a business and make money despite the delta in machine uptime. But on the flip side, to really be competitive in the next phase, especially in this macroeconomic time, really squeezing out every bit of efficiency is going to be mission critical for every manufacturer. And there's this concept of bullwhip effect, which is small changes at the end customers, whether it's buying cars, whether it's any other product, have these massive ripple effects for folks down the supply chain, and especially for manufacturing. And so we're in a unique time in the world where demand is shifting every couple of months in a substantial way, whether it's in prices, whether it's in volume, and really building that those systems in place to be lean and optimizing your operations are going to be key. So typically folks are asking themselves, how do I really expand my margins to keep up with these rising costs? Are my standards for different part numbers really accurate, or do I need to update them? Who are the top performers on the shop floor that are really getting parts out and keeping these machines running, that we really need to reward in this talent war? Do I need to buy a new machine, or should I invest in automation? How many people should I really be hiring? Is my tool room or my quality team being a bottleneck in my setup times? There's so many questions that keep popping up in day-to-day operation. And how do you really get those answers? And what we've seen in best-in-class companies is to build a system to block and tackle these issues. And it starts with having a quantified goal that you can track in a reliable way, identifying the root causes whenever those goals are missed, and finally building continuous plans to solve those issues. And before diving into this case study, is one final anecdote. There's a movie called Moneyball, which I'm sure a lot of you have seen, and it talks about the Oakland baseball team and how the GM was able to really use data despite having limited resources in winning the World Series. And I often think of the breakout rooms, the shop floor, similar to this, which is there's so many constraints and resources, whether it's in capital, whether it's in hiring, and how do you really get those decisions that optimize the limited resources you have. So that's kind of some of the inspiration that we have when we work with manufacturers. And so really, I'm going to be talking about a couple of examples, but it starts with having that data at your fingertips to make those decisions. So these are some of the top issues that we've seen in gear manufacturers and machining manufacturers, which shouldn't be a surprise to anyone on this call, which is limited manpower, setups and changeovers taking longer than they should, waiting on support resources, whether it's quality, programming, maintenance, and finally it's missing resources like tools, gauges, and so on. I'm going to be going over some case studies to share how folks have been able to not only quantify this, but what kind of solutions have they found around these bottlenecks. So the first case study is with a company called Fusion OEM. They're based just outside of Chicago, where Amper is based off of as well. And just like any other manufacturer, they faced challenges in labor shortages. Their on-time delivery metrics had increased expectations, and limited number of machines where they were running out of capacity, and had all kinds of decisions from outsourcing to insourcing to be made. And as they started quantifying where the downtime was really going, they began to see, as they create a Pareto, that a lot of this time was going towards loading, unloading, shift changes, and then waiting on material. And so by quantifying this data point, and also visually, if you see their shop floor, for example, this shows a timeline of the machines through the week. And the green means cutting metal in production, yellow means idle, and the red means the machine is off. You can see how the machine utilizations were like 20, 30, 36, 24, and just the amount of idle time in between. And so this company, there's mainly Haas machines, high mix, low volume, and they ultimately invested in automated tending by justifying that investment with data. And as you can see, just visually, the difference. There's a caveat: you have to have the right part numbers that can sustain, automated tending. But it added so much capacity for the right machines that they were able to confidently invest in these automation technologies. So another great case study is with our customer, Mitatech Precision. They're based in Needham, Wisconsin. It's relatively rural, so sourcing skilled machinists is incredibly challenging over there. And they knew they needed to hire more employees, which is an obvious statement, but how do you really go about it? How do you really tie shop floor data to a hiring plan that makes sense? And so they started to label every single minute of downtime to really model and justify what's happening. So not only did they save about 5 hours a day by not having pen and paper, having that transcribed into an ERP, and just the data manipulation that went into it, but they started to really automate this data collection first. The next is by having this information in one place in an accurate way, they were able to really understand where they were losing time. And you'll see over here, this is a screenshot from their dashboard where they uniquely had downtime codes driven around actions. So need to hire, for example, or need to hire a setup machinist, as you see over here as a third reason code. And so what was really interesting was how they were able to make these codes actionable. And they quantified this and saw just how much capacity they were losing by not hiring, and used this to justify what kind of roles they needed to hire, as well as justifying a sign-on bonus, for example, just because of the opportunity cost of not taking action. And this was kind of what the interface looked like, where operators simply had to one-click choice on which bucket of downtime time was going against. And so you can kind of see over here on this dashboard, they could quantify that they needed to hire general operators. They lost 71 hours, for example, that week because they didn't have a setup machinist. And you can start to really apply your hourly rate or cost of capacity, or your cost against your burden, your backlog, to really understand what does it cost to not make those decisions. The second thing that they did was, at the end of the day, it's really the operators are trying their best to get parts out, get the machines up and running, but there are process issues that continue to be bottlenecks. This can be anything from waiting on a programmer. This could be waiting on a maintenance technician to help fix some issue. And what they did was they implemented this communication tool where an operator, right from the machine, again, with a similar system, they could just tap on which resource they needed to get help from, and really empower those folks to raise their hand and get that help. The next is, setup times are this black box, which is setup is a big issue. It's high mix, low volume. And, the typical solution is, we need to hire more experienced machinists and train by osmosis. But Mitatech, took it to a different level where they really used this setup tracking tool where they outlined each step in the process, from tear down to clean up, and started to use this really as a way of tracking and understanding where really is the bottleneck in the setup process. And by having this data, they were able to run SMED events, which is single minute exchange of dies, to take out all those parts of the setup process that could be prepped outside of it. And they were able to get the right tooling cards and so on in place through this data. And ultimately, they saved about $600,000 by removing that unplanned downtime and process issues and things that are really controllable within the business, things like faster response times and so on. And conversely, they were able to identify, across the shop floor, 40 hours a day in planned downtime, which means they didn't have that role filled, or it was a setup time that they were optimizing. So all in all, it was roughly 1.4 million in savings in 11 months that was fully quantified, and they had a list of improvement projects really nicely documented. When it comes to the topic on how small and mid-sized manufacturers can get started with Industry 4.0, this is a great example because it takes away the technical terms that often go into industrial technology. Things like MES systems, SCADA, PLC integration. All of that is definitely a means to an end. We're all trying to drive lean manufacturing, and the tools that I went over, like and-on communication, where folks can get help as they need it, or really understanding the root causes of downtime. It has nothing to do with in a way a technical term or technical implementation. It's simply using technology to augment a process that already is probably being done slightly inefficiently. So another quick case study to kind of go on with the practical examples is with a customer of ours, Hydroforce. They make hydraulic manifolds and cartridges, and they use a similar and-on system to have operators raise a hand, get help. But what's really interesting about this is they track the response times. So the response time is from the time an operator raises the hand, asks for help, how long does it take to get back to the machine and support that operator? And with this tool, they were able to track how long each support staff is really taking in getting to the machine. And what they saw was, the maintenance team had a 70-minute response time, which was longer than what they wanted. But when they double-clicked on the data, there were too many requests sent to the one maintenance individual that they had on the shop floor. And so this data was able to not only reveal, downtime issues, but also support resource and staffing decisions that are very practical. So again, your processes might be bottlenecked not only on the shop floor on folks not getting the machines up and running, but it really could stem from the front office, so to speak, whether it's engineering, quality, tool room, and so on. So this is just a live example of what that might look like. So folks can say, I want to call a team, a new call, select which team, type in a message. So another really great example is with our customer Precise Tooling. And as a mold maker, facing global competition and rising customer expectations when it comes to on-time delivery. And this company did a similar exercise of really identifying, where they were losing time. And what they saw was, a lot of the downtime was driven by tools. And some of it was missing tools, some of it was, tool changes. And they were able to similarly quantify, how much time is really being lost to missing tools, and we're able to justify investing in those and having dedicated tools for each machinist. And it comes down to these cycles that we like to frame, which is we want every person on the shop floor to be talking about the same data, so that there's reliability on what information decisions are being based off. And we've seen 3 different cycles in decisions. So the first cycle is on a daily basis, which really is around responding quickly to issues and having visibility in real time so that decisions can be made proactively. So things like visualizing these metrics on the shop floor, escalating alerts, say when a machine has been down for say 2 hours or an hour, empowering operators to get the help they need when they need it, and saving that time that typically goes into like, tally sheets, manual data entry, and automating as much of that, data entry work. And this visual management with real-time data and those communication tools really drive an increase in uptime just by folks being more proactive and shrinking the response time to issues. There's also benefits like in the middle of the day, let's say you have an issue and folks need to work overtime or customer expectation needs to be changed on delivery dates. You can get ahead of those instead of at the end of the shift when an ERP creates that report. The second loop is, say, on a weekly basis around, what areas should engineers really be focusing on? When you run your production meetings, having reliable data so that most of the meeting isn't spent on figuring out what really was the issue, and instead focused on a plan to really solve the root cause. And finally, when it comes to scheduling and capacity management, having that accurate data on what's really been happening can help on that in the weekly cycle. And then finally is on a monthly cycle, making or quarterly cycle, make those big decisions on things like whether it's buying new machines, whether it's adding a shift, whether it's adjusting, a core process, or when you identify that, say, the cycle time of certain process isn't really what is in the system as a standard, making those changes so that your margins are protected. So I found this to be a nice way to kind of frame how can data weave into these decisions in a very practical way. And so, how do you really take your first steps? At the start of the talk, I mentioned, lived in the environment of, having limited resources in, adopting these kinds of technologies. And these are the three things that we've typically seen be hurdles in digitizing the shop floor and really getting started with these technologies. It starts with limited IT resources. I don't know any manufacturer that can say I have way too much IT resources. There's so much work that goes into, even just maintaining an ERP. So the last thing they need is, a 6 to 12 month implementation on data collection. The second is machine integration. Most shop floors have a mix of new and old machines that may not talk the same language. And sometimes, machines may not even have a PLC to read data off of. We've seen stamping presses that might be like 80 years old, all the way to brand new machines that sit right next to each other. And so how do you really integrate everything into one system? The third is unclear use of data. You collect all the data in the world, but how do you really frame it and use it in a very practical way? And then finally is, the cost that, these projects typically go on to when you combine upgrading IT systems, PLC integrators, IT integrators, maintenance fees. The cost can typically really balloon with technologies like this. And the idea of, collecting machine data, having this at your fingertips isn't novel. It's been around since the 90s in a way, but the industry just hasn't had the right tools to make that leap. And that really was the inspiration for Amper. We built a tool with those 4 constraints in mind and have a really unique system. So, both on the implementation, but we also have a hands-on team that, works with our customers post-implementation that are 6 Sigma black belts, 6 Sigma green belts. And on a monthly basis, we ensure that the data is being used the right way. There are practical ways and continuous improvement projects that are being spurred from this information. But coming to the core technology itself, this is a patented technology where it's simply a non-invasive sensor that is clipped around the spindle's electrical wire or any other motor's wire. So it takes just 5-10 minutes to just clip it around the right wire. We use machine learning technology to translate the heartbeat of a machine in the electrical signals into operational metrics. And this can be seen in real time on your dashboard, on your phone. And so what this means is that you don't need to worry about IT integration, PLC integration. It literally just takes 10 minutes and you're up and running. And so typically this is the point that we come in on, folks' journey and taking the shop to the next level, which is, you probably have some system, whether it's an ERP system, and you've got a long journey ahead with technology. And the bridge that we help our customers close is, how do you go from lagging indicators and reports that may not be as accurate to real-time information? And finally, we have a free trial system where we send out a box like this that has all the things you need to test it out on 2 machines. And our team works with you closely over that entire trial period, where we collaborate on project ideas, on continuous improvement projects that might be spun from the data, and all of this is completely free. And so you're able to, at a minimum, use this program, to create a baseline and identify what's really happening. And on the upside, if it's the right system, you have tested out the technology, built internal support, validated, all the things that really matter, and have taken the product for a spin. So that's just a quick recap of Amper. Happy to kind of answer any questions, but Mark was kind enough to take some time off for this call today, and we had a couple of questions to just kind of bounce with Mark. Mark, maybe you want to give a quick introduction, and we can dive into that right off that.
Sure. Good afternoon, everybody. So I'm Mark Ritchie. I'm the general manager of Gleason Cutting Tools Corporation in Northern Illinois. Like a lot of our customers, we're also a high mix, low volume type manufacturer. We kind of look at ourselves as a really big job shop. We got approximately 350 machine assets on site that are a mix of CNC as well as manual machines.
Thanks, appreciate that. So Mark, we met a few months ago, and I'd love to kind of ask, what led you to looking into shop floor data collection?
With a lot of the hiring troubles people are having, we were trying to find ways to do more with less. We're trying to find, how do we get more capacity, more throughput, more efficiency out of especially our bottlenecks. About 25% of our machines are considered bottlenecks in our facility. Part of working on those bottlenecks is to reduce lead times, improve our cost points, things like that. So we started in this investigation of what kind of systems are out there that are available that might be able to help us in that journey.
Yeah, absolutely. Gleason's been around, for a long time. What really held back the company from implementing something like this over the years?
Well, we had tried several solutions. A lot of them took, a lot of IT support. A lot of them took manufacturing engineering people to go through and really dig through the data, kind of sift and understand. But it was all lagging. It was stuff that we would get, and then at the end of each month, we would go through and review it. And it became very cumbersome, and ultimately it failed on the shop floor because it was just too difficult to use and implement.
Yeah, no, absolutely. And that's, it's definitely a challenge when you don't have all the resources in the world to get systems like this going. I guess if you don't mind, just sharing a little bit about, what was some of the learnings from the Amper trial, just if you want to kind of give your perspective on how the trial, kind of unfolded.
Yeah, absolutely. So, we started an investigation of several different companies, and we actually used an outside source to help us identify potential companies that could come in and help us through this journey. We ultimately settled on a few solutions, Amper being one of them, to go through a trial. Just like Akshat put on the screen, they sent us a box. It had some simple components in it. They said, okay, we'll take this out to your machine and get it connected. So we actually took our manufacturing engineering manager and gave him the box. He went out to the shop and he connected this kit in roughly 5 to 10 minutes. So that was impressive right out of the gate. We're able to see something happening pretty quickly. It didn't take a bunch of maintenance people or, special connections trying to plug into PLCs and controls. Literally just clips onto a couple wires and we're able to start basically registering data. From that point, we had a few discussions about an interface, which we used a simple $100 Google Android type tablet that we put out at the machine. So every time the machine would go down for any kind of a reason, whether it was setup, inspection, so on and so forth, we wanted to know, what is the unproductive time? What are we losing on this bottleneck? How many hours? And so we made this simple interface like Akshat showed earlier, and the operator would literally just click a little button on the screen and it would register that information until the spindles kick back on. From there, they helped us look at what data we were getting, get an understanding of, what potential projects or ideas that we could put in place to help us improve our overall uptime and efficiency. So as we started measuring OEE, we started on a bottleneck resource of a precision form grinding machine of roughly 35% OEE. By the time we finished up with this first initial trial, we were closer to the 80-85%, just by understanding better, where our downtime was, why we had it. Everybody thought they knew, but at the end of the day, they didn't really know.
Yeah, I mean, it was really incredible. I think there was some great low-hanging fruits and setup times, and just putting the number out on the shop floor, I think, was also a great move in not just being a tracking system, but really a team goal that everyone really got around. So I think the team did an exceptional job with messaging it the right way on the shop floor. I guess, what advice would you have for folks when, bringing up a solution like this? Because obviously a lot of big brother, that comes with in perception. I'd love to kind of hear your advice to other manufacturers looking at introducing this concept to the team.
Sure. A lot of what you're seeing in Industry 4.0 is like you said, big brother, big data, a lot of these complex things. So when you go out and you look for a system that kind of helps you understand your throughput efficiencies, where your downtime are, you're really looking for a system that's going to be simple, easy to use, real time, as Akshat had mentioned in his presentation. Gives you the ability to react quickly. With data, a lot of people tend to, they close a month, they go back, they look in time and they say, oh, well, we had cost overruns here, or we had efficiency issues here, but now it's in the past. What we looked for when we were looking for a system is something that was real time, something that we could go out and look right away, was visible, it was digital. Everybody on the shop floor could see it at every given moment. And that was important because it helps you get everybody involved and on board with the process. It's not just, well, the operators now think that everybody's got a thumb on them and we're trying to watch them through cell phones and computers behind the desk and make decisions about what they're doing. But, it was more about, how do we get inclusivity with everybody? How do we get the shop floor guys involved? How do we get, maintenance involved, the people in the office, and everybody working together on the same team?
Yeah, I really appreciate that. I guess just going to close out, any other advice or things you'd kind of recommend manufacturers, whether it's, initial, scope or problems we solved, or what kind of machines they should choose when they, do a trial, say on 2 machines?
Sure. I mean, the process we use, we pick bottlenecks because that's where, we're looking to get the most throughput and efficiency. That's really why it's the bottleneck, right? We've looked at and we will be installing several devices over the next few months on both CNC and manual machines. With the manual machines, it's going to be really interesting because typically with these kind of processes and technology, you have to have controls or PLCs that you integrate everything through to get you the data back. And we're pretty excited to see some of our more manual bottlenecks to actually be able to be captured and see where we can improve at.
Yeah, no, absolutely. No, thank you so much for sharing that. And, again, your team did a great job with, having very clear objectives and involving everyone from the operator to the maintenance team to executives. So I think it's an exciting journey ahead. Really appreciate that.
Yeah, thanks, Akshat.
All right.
Hey,
So
Akshat, I'm sorry.
oh, I
Before
think
you,
go ahead, Mary. I'm sorry.
no, I'm sorry for interrupting you. I have a couple questions that I think will fit in right here before you move on.
Absolutely.
How involved is Amper in the testing phase? For example, for lights out production at a facility, and what sort of training and experience does your customer need to have to make it work efficiently?
Yeah, that's a good question. So we're very hands-on in the testing phase. So you get a dedicated implementation manager so we initially have a 30-minute kickoff call, and on a weekly basis, we set up 30 to 45 minutes, for continuous training, for Q&A, and again, really collaborating with you on, what kind of projects and use cases really matter for your shop floor. So we work really, really closely and throughout that, 30, 40 days in trial. And in terms of lights out production, the training and experience really comes to the installation of the system, which again is really simple. So as long as you can identify, the wires that drive your machine, you can install it in 10 minutes. The software is really easy. We do an onboarding so that you're comfortable with it. But in terms of budgeting time, you can allocate about 10 minutes per machine to install the system. And then again, like about 30 minutes a week to talk to our team for training and Q&A.
That's great. Thank you. I know you're moving into a demo of the product. So as you move into that demo, the other question is, how much does this cost? And being a small manufacturer, we don't have a big IoT budget. So as that works for you.
Yeah, absolutely. Happy to just answer that out the gate. So we have a really unique business model. Instead of sharing, 20 line items with, user licenses, consulting, implementation, we have a single line item that includes the hardware, software, unlimited users, and all the different software features. So it's really simple, and you know exactly what you're signing up for. Roughly, it is $100 a month a machine, and we do have, ways of scaling the discount through different levers. And typically folks get started with around 20 machines is what we've seen as typical. But yeah, it's a really simple pricing model. It's very transparent. The only additional cost that you might have to bear is in the tablets for the machine, for the operator interface.
Thanks very much.
Yeah, you got it. All right, so let's pivot over to the demo. So the first thing we're going to cover is this live scoreboard. So this gives you a real-time 30,000-foot view into your shop floor. So over here we can see these 9 tiles that show various machines on a certain cell or on the shop floor, and it shows some key metrics. Some of these are automatically captured. Some of these might need someone to actually just give that context. So for example, we can see over here the machine started with production. There's some idle time, again back to production, and so on. And through our automated cycle counter, we can even see the total number of parts produced, which will also give the cycle time. You can see over here there's a call for help for raw material that's been waiting out for 2 hours. So we're going to pivot over to the machine operators tool to kind of share how this information really gets entered. So right here we can see for this machine, the machine was down from 8 to 9:22 in the morning. And all an operator needs to do is say update. You can create your own downtime reason codes. And let's say waiting on quality. They can add a comment, but simply hit submit. And the downtime reason gets tagged immediately. So it doesn't take much input from the operator to get this information. This is the place where folks can call for help from the rest of the team. So all they do is say, I'm going to call a new team. I'm going to call my programming team. They can type in a message, and a text message or an email gets sent out to the right person. So it's really simple. And in addition, this is, for example, the the work instruction, the work checklist tool, where folks can essentially start a setup, for example, and as they're completing different tasks, move on to the next one, or skip over to another step. And operators also have access to putting in maintenance requests right from the same interface as well. So going back to the software interface, I want to show a couple of quick features that highlight the use cases. So let's say we want to take a broader view of the business and get an executive summary on what's been happening, say for the last 30 days. So dashboards like this give context. For example, the average uptime was 58%. These were the top reasons for downtime. This is how different shifts performed, as well as metrics like different cell performance, machine performance, and so on. And all these reports can be automatically delivered through an email, let's say on a weekly basis or on a daily basis. And in addition, you can also begin to really toggle and understand how capacity is really being managed on the shop floor. So let's say I want to see by machine and by week for the last couple. This is demo data, so obviously looks like a perfect gradient, but this gives you a sense of week over week what the capacity was for each of these machines. You can also change this to looking at by machine and operator, so you can identify which operators are performing and which machines the best way, at the highest productivity. So over here we can see similar data. You can also see by part number and by operator. Potentially certain operators have a better processes in place for setting up a machine or keeping the machines running. You can really slice and dice this data to understand coaching opportunities as well as other areas for improvement. So for example, over here on this part number, Stephen I was able to have 84% uptime. It's worth looking into, what is he doing right that can be transferred across the team. Now, going into more tactical downtime information, here's a really great dashboard where you can filter out, let's say by the top reasons, by machine, and by operator. So I can see over here that we lost 369 hours in tools over the last week. And if I simply click on this, I can drill down to which machines face this bottleneck. And so I can see Mazak number 2 had this issue. If I click on this, I can drill down to which operator was running the machine. So I can really look into what the root causes were. I can even see the sub reason over here. So it was tool change and missing tools. Now, conversely, if I click on maintenance, I can see how much of it was unplanned versus planned, as well as which machines had this issue. You can also set up those proactive alerts on Amper. So let's say I want to set up an escalation alert, say escalation level 1. If the machine's been down for, let's say, 30 minutes on a certain group of machines in the first shift, I'd like to get a text message, and maybe someone else on my team can get an email. And so what we've seen a lot of customers do is set up multiple levels of escalation so that as issues are cropping up, the right people are notified, as opposed to learning at the end of the day that half the parts were made or some important schedule was missed. And Amper also has a built-in maintenance software. So this is a complete CMMS software where you can track work orders and assign different PM activities to the right folks. And what's really neat about this is because Amper collects real-time data from machines, we're able to also create usage-based schedules. So for example, you can have a spindle inspection after 1,500 hours the machine actually runs, as opposed to annual or quarterly, especially since certain machines are used more than others. So you're able to avoid over-maintaining machines that aren't used a lot, or under-maintaining machines that are used a lot. And beyond this, we have all kinds of analytics around things like setup times. As we talked in the case study, for example, you can see which specific part of a setup or changeover is taking the longest time, by which machine. and you can run setup production activities based on this. And this is the response time analytics tool where you can see, by team, by individual, how long setup response times are taking and what the trend line might be over there, as well as the frequency of calls to different teams. So for example, the maintenance team got 89 calls in the last week. Potentially there's a staffing or a training opportunity over there. So all of this to say, Amper ultimately helps avoid production surprises by escalating problems in real time. It gives the data you need to understand the root causes, and it has the tools for your workforce to feel empowered and have the the communication and resources to hit the numbers. So that is the end of the demo. We have about 10 minutes left for the webinar. I'd be happy to answer additional questions if there are any.
Thanks so much for that thorough overview of Amper. I really appreciate that. My first question that hasn't been posed yet is, where do people get their free trial? How do they sign up?
Yeah, that's a great question. It's very simple. We've tried to make it as easy to request. So you go on our website or contact us directly. We have a simple call out on requesting a free trial. There's a small form that you can fill out. We have a small kickoff call to make sure that you feel empowered to do the trial the right way. And we just kick it off. So really simple, you go on the website, click the free trial button, and typically we send it out within a day.
And is it just in the US, or is it available in Canada or other countries as well?
While we do most of our trials in the US, we've made exceptions for deployments in Canada and Mexico.
Great. Well, thank you very much. I'd like to open it up to those that are on this call. Does anyone have any additional questions? I really think you did a thorough job.
Thank you.
Well, great. If there aren't any additional questions, thank you so much for this presentation. For those of you that are on the call, this will be taped, and if you need to share it out, it will be available on the AGMA website in the Emerging Technology tab, probably tomorrow, and we can share it out at that time. So thank you again. What a great presentation, and I look forward to speaking to you more in the future. So everybody have a great day.
Thank you. Take care. Bye.